Welcome once again to the webcast series put on by Pattern Discovery Technologies discussing our product CompressionInsight. At this point we've got the product installed, so we've downloaded it from our website and installed it successfully on our machine. And what we'll do now is take a look at the first steps that you'll typically go through when you run CompressionInsight. First, starting out with a user interface overview. We'll look at the different pieces of the application and the different areas of the UI experience, and then we'll add some tags, and we'll see that there's two ways to add tags. The first is the very typical way of adding tags from your Pi server using the tag search dialog, and the second way is from copy and paste from your clipboard. So let's jump right in. What we're looking at now is CompressionInsight. The tool itself has three main areas of the user interface. The first here is what we consider our navigation pane. So this is going to show all the tags that you have included in CompressionInsight for analytics, and those tags are going to be organized in this tree according first to the state of the tag. So that if the tag is included, if it's in manual mode, or it's currently in invalid state, and if it is included, then when will analytics be ready? So this is a forecast of when we'll be able to make a reasonable recommendation based on the amount of data that we've seen from the tag so far. The main screen here, this is our document view, and what we're looking at right now is an empty summary. This summary screen will show you a grid view of all of your current analytic results and some details. Okay, when you actually have something to see, we can see some charts. So why don't we go ahead and jump right in and add some tags. So again, there's two ways to include tags. The first is to include tags from the Pi server. The second is to include tags from the clipboard. So if I include tags from Pi, note the fact that I'm connected here to my Pi server blue. This is my default Pi server. And in this case, I'm going to choose to search by tag mask. So I've set up a few test tags here that I like to use for running demonstrations. You can search any way you feel like it, by engineering units or point source or type or whatever. This is the exact same dialog that's used in many of the OSI soft tools. So I'm going to go ahead and select these and add them to CompressionInsight. Again, we see this warning dialog, which really is just reminding you that we need to make some changes to the exception deviation settings for the tags that we've chosen to add here. Okay, we zero out the exception deviation so that we see more data, but we do remember what the original exception deviation values were when we first included those, so we can set them back. So now we're going to add these tags. Basically, what's going on now is the client CompressionInsight communicated with the engine and asked it to please register with the Pi server and start collecting snapshot data for each of those tags that we included. Okay, and here's a set of the tags that we just included. What we do based on the snapshot values is we make an estimate of the scan rate for those tags. I know that each of these tags has a 1 second scan rate, and so we're estimating that because we haven't done analytics yet, that it's going to take quite some time to actually get enough data to produce some reasonable recommendations. So what I'm going to do is force a refresh of all of our analytics, which will then recategorize all of our tags here and make a better guess as to when analytics will be ready. Clicking the refresh button will take, this is the pane that shows all our server details. And so each of these are analytics jobs that are going to be run as quick as they can by our analytics engine. So what we can see here now is that we've refreshed, and so now it's less than a day to collect enough data to actually make a reasonable recommendation. Let's clean up the UI here a little bit. For my summary view, I'm only going to want to look at certain columns here. Okay, let's start with that. So what we're looking at is a summary view of all the tags, the snapshot data counts that we've seen so far in our analytics, the current exception and compression values. Okay, and as we scroll over, we'll see the current information retained. So this is a critical column here that we'll talk about a little more when we get to the detailed view. The current count, this is how much data you're actually storing relative to the snapshot. So in this case, you're storing 1.1% of all the data that comes in. And here's our first go at a recommendation. Now we've got some color coding going on here, and you can see that this green correlates to what we call unusable. And what that really means is that we haven't seen enough data yet to make a reasonable recommendation. And so we've got to wait a little while until we actually see enough data. So we can see now that we've let the tool run long enough to collect sufficient data. We now have a few 100,000 snapshot values. We've forced analytics to run again so that we get good counts, and we see that all of our recommendations here are shown as being ready, so that we can actually trust in those recommendations. So we can do some filtering down here at the bottom. And if we turn off low and medium confidence recommendations and only keep the high confidence recommendations showing, we can see the level of improvement in the recommendations that are made. But if you click on the tag itself, you bring up what we consider a detail pane. And so we can see a chart of the signal itself along with our recommendation and what your archive would look like at your current levels. So this table shows, here's our current settings, the exception and compression values, data counts, information retention, and the percentage of data archived. And here's our recommendation. So we can see that our recommendation reduces the exception deviation by about half. Does the same for the compression deviation. We have 230,000 snapshot values. Of those 230,000 snapshot values, you're currently storing about 35,000 of those. Our recommendation is going to store near 50,000 of those snapshot values. But you can see that our information retention goes from 64% to 84%. And our data archived percentage increases a little bit as well. So if we clean up the UI here a little bit and zoom in a little bit, we can see, let's turn off, here's what our snapshots look like. And this is what your archive values would look like. And so you can see, this explains the low information retention. Again, the snapshot value here in gray, the snapshot value isn't being traced very well by the archive value. If we look at our recommendation now in black, again, our recommendation is tracing a little better against the snapshot value, and that explains the higher information retention. We can pick some other random area of the curve here and see the same effect. So that's one of the tags. We can have a look at any of the others, but before I do that, I'm going to sort it according to the improvement in fidelity. Okay, so here's another tag. Again, according to current exception and deviation values, we're retaining 44% of the information stored in the original snapshot. But here in this tag, we're actually storing an awful lot less data. So of 228,000 snapshot values, we're only storing 1,000 of those, or about 0.5%. Our recommendation is going to increase that storage, and so we're going to almost triple the amount of data that we're storing here, but that our information retention is going to go up accordingly as well. And when we zoom into the curve, we can see, looking at our snapshot values, this is what our archive would look like. And so that's not great. Our recommendation traces a little better, against the snapshot value, and that explains the improvement in information retention. These tags, all these tags are in automatic mode, and so what that means is that we'll automatically come up with a recommendation that acts as a trade-off between fidelity and bandwidth. I think we all know that if the more data you store, the higher the data fidelity you're going to achieve. If you store 100% of your data and you turn off compression, then you're going to get 100% data fidelity. And the trick here now is to pick your exception and compression levels so that you can maintain fidelity but reduce data counts a little bit. And so our automatic recommendations here look to achieve that. So we can see here our fidelity change here is an improvement of 33%, 26%, etc. You look at other tags, kind of here randomly and zoom in, we can see the same effect. Okay, so our snapshot's bouncing around a little bit here. The archive sometimes doesn't trace it, very nicely based on current levels. Our recommendation does a little better of a job here. Okay, and so that's our summary screen, our detailed views. We can close them off. We can do some tricky things like rip this off and then, dock it to the side of the window here. It's a fully dockable user interface experience. But that's our first steps. That's the UI and how to add tags, and then adding tags specifically from the Pi server. If we want to add tags from the clipboard, then we would just use the Add Tags from Clipboard menu item, and this gives us an opportunity to paste from an Excel column or a row, a space delimited row, or a comma delimited row. The times you'd use Excel are if you're using the DataLink SMT tool to gather some statistics on your archive values, and maybe you're storing too much or storing too little, and you can determine that from Excel. And then you'd use this functionality to add those tags. Once the tags are added through these buttons, they'll be verified through the application and allow you to add them. So that's adding tags and our UI walkthrough. Thanks for watching.